Take a deep breath and allow your body to settle into the stillness of your surroundings, letting the weight of the day dissolve into the surface beneath you. As you exhale, feel your mind begin to drift away from the terrestrial world, moving upward and outward into the velvet embrace of the silent, waiting cosmos. We begin our journey 26,000 light-years away from the familiar warmth of our sun, traveling toward the very heart of the Milky Way galaxy. To understand the scale of this distance, consider that light, which travels at roughly 186,000 miles per second, must journey for 26 millennia just to reach the center from where we sit tonight. As we approach the galactic core, the familiar patterns of the night sky begin to shift and dissolve. In the direction of the constellation Sagittarius, the stars grow increasingly crowded, shimmering with a density that the human eye, bound by the limitations of visible light, can rarely perceive from Earth. This is because the core is shrouded by vast, silent veils of interstellar dust that block nearly all visible light, attenuating it by a factor of 25 magnitudes. If you were to look toward the center with your own eyes, you would see only a dark rift in the sky. But as we move closer, we switch our perspective to the infrared and radio spectrums, allowing us to see through the dust as if it were a thin, ghostly mist. The texture of the space here changes. It feels thicker, charged with the ancient energy of billions of years of stellar evolution. We are entering the galactic bulge, a massive, roughly spherical heart of stars that stretches nearly 10,000 light-years across. In the solar neighborhood where Earth resides, the space between stars is vast and lonely, with an average of only 1 star per cubic parsec. But here, in the inner sanctum of the galaxy, the density increases to over 1 million stars per cubic parsec. Imagine the sky above you not as a dark void with scattered points of light, but as a brilliant, perpetual twilight, where the stars are so close that they would cast shadows on any world lucky enough to orbit them. These stars are elders. Many are over 10 billion years old, rich in heavy metals and glowing with a steady, amber hue that paints the vacuum in shades of gold and copper. As you float through this dense stellar city, you might notice the profound silence of the movement. Gravity is the silent conductor here, orchestrating a dance of unfathomable complexity. This is the central molecular zone, a region about 1,000 light-years wide that contains nearly 30 million solar masses of molecular gas. This gas is cold, perhaps only dozens of degrees above absolute zero, yet it is the nursery from which new stars are born. You can almost feel the chill of these giant molecular clouds, their surfaces textured like soft, dark velvet, swirling in a slow, rhythmic rotation around the hidden center. Deep within this cloud-filled region, we find the Arches cluster, the densest known star cluster in our entire galaxy. It is located roughly 100 light-years from the very center of the Milky Way, containing thousands of young, massive stars packed into a region only a few light-years across. The light here is intense but cooling, a brilliant contrast to the ancient red giants that surround it. Consider the pressure and the heat of these celestial bodies. Yet from our vantage point of weightless observation, they appear only as soft, glowing embers in the hearth of the galaxy. We are drawn further in, toward the dynamical center known as Sagittarius A star. Here, the laws of physics reveal their most elegant and terrifying beauty. At the very heart of the Milky Way sits a supermassive black hole, an invisible anchor with a mass of approximately 4.1 million times that of our Sunday. While its influence governs the entire galaxy, its physical size, its Schwarzschild radius is surprisingly compact, measuring only about 12 million kilometers. To put that in perspective, this gargantuan object would fit comfortably within the orbit of Mercury. You cannot see the black hole itself, for it is a point of no return, but you can sense its presence through the frantic yet silent motion of the stars that surround it. These are the stars, a group of high-velocity stars that perform a daring orbital ballet around the central singularity. One star in particular, known as S2, completes a full orbit every 16 years. At its closest approach, it reaches a staggering speed of 7,000 kilometers per second, nearly 3% of the speed of light. Watch as it swings around the invisible center, a pebble caught in a cosmic whirlpool, moving with a grace that belies the immense gravitational forces at play. Despite these incredible speeds, there is no sound, no friction, only the smooth, curved geometry of space-time guiding the star on its path. As we hover in this region, notice the G objects, mysterious, dusty clouds like G1 and G2 that look like gas but behave like stars. They stretch and deform as they pass near the central black hole, their outer envelopes of gas being pulled into long, glowing filaments by tidal forces. This process is slow, taking years to unfold, a testament to the patient timescales of the universe. The temperature of the gas in this inner parsec is millions of degrees, emitting a soft, ethereal glow in the X-ray spectrum, yet you remain comfortably cool, a mere observer of this high-energy theater. Stretching out from the core are the Fermi Bubbles, two colossal structures of gamma-ray and X-ray emitting gas that extend 25,000 light-years above and below the galactic plane. They are the remnants of a massive energy release from the core, perhaps from a time when the central black hole was more active, consuming matter with a ravenous appetite. These bubbles are so vast that they dwarf the core itself, shimmering with a faint, ghostly light that speaks of the galaxy's violent and majestic past. Nearby, we encounter the Great Annihilator, a microquasar known formally by the designation 1E 1740.7 to 2942. This object is a stellar mass black hole that produces twin jets of positrons and electrons, stretching across light-years of space. It is a reminder of the sheer variety of wonders hidden in the core. Along with it, we see the radio filaments long, thin threads of magnetic energy, some reaching up to 150 light-years in length. They stand vertically like the strings of a cosmic harp, aligned with the galaxy's magnetic field. Scientists believe these filaments are formed by the interaction of high-speed particles with the magnetic lines of force, creating a structured, geometric beauty in the midst of the swirling gas. The rotation of this entire region is a masterpiece of celestial mechanics. The Milky Way spins at a rate of approximately 220 kilometers per second at our Sun's distance. But here in the core, the rotation is even more complex. A single galactic year, the time it takes for the Sun to orbit the center, is about 230 million Earth years. As you drift here, you are witnessing a moment in a cycle so long that entire species on Earth have risen and fallen in the time it takes for 1/4 of a rotation. There is a profound comfort in this permanence, a sense that the galaxy is a steady, beating heart that has functioned with clockwork precision for over 13 billion years. The chemical composition of the stars here is also unique. Because the core has been a site of intense star formation and death for eons, the interstellar medium is enriched with metals, elements heavier than hydrogen and helium. These elements, forged in the hearts of dying stars and scattered by supernovae, are the very building blocks of planets and life. As you look at the glowing dust and the brilliant stars of the core, You are looking at the furnace where the universe prepares the ingredients for existence. Every atom in your body was once part of a cloud like these, perhaps even here, in the very center of the Milky Way, before being cast out into the spiral arms. The sensory experience of the core is one of overwhelming light and intricate structure. The light is not just white. It is a spectrum of deep infrared reds, brilliant X-ray blues, and the steady, golden glow of the nuclear star cluster. The texture of the space is carved by magnetic fields and gravitational tides, creating ripples in the gas that look like the surface of a wind-swept ocean. The temperature varies from the absolute cold of the molecular clouds to the millions of degrees in the plasma jets, yet it all exists in a harmonious, silent balance. You might wonder what it would feel like to stand on a planet in this region. The sky would never be truly dark. With stars packed so tightly, the night would be as bright as 1,000 full moons, a kaleidoscope of colors and shapes that would fill every corner of the horizon. But here, in our journey, we do not need a planet. We are weightless, drifting through the vacuum, feeling the gentle pull of the galactic center as a comforting, grounding force. This is the anchor of our home, the pivot point around which everything we know revolves. As we conclude this first segment of our exploration, focus on the scale of what we have witnessed. From the 4 million solar masses of Sagittarius A star to the 10-billion-year-old stars of the bulge, the galactic core is a place of immense power and serene beauty. It is the densest, most energetic part of our galaxy, yet it moves with a slow, rhythmic grace that invites you to let go of your worries and simply observe. The distance of 26,000 light-years is no longer a barrier, but a bridge, connecting the smallness of our world to the vast, enduring heart of the Milky Way. Allow yourself to sink deeper into this realization, feeling the cosmic clockwork ticking away in the background of your consciousness. Steady, certain, and eternally calm. You are a part of this system, a traveler in a universe that is both vastly complex and beautifully simple. Rest in the knowledge that the center holds, and the stars continue their ancient, silent dance. Imagine the year 1785, a time when the world was illuminated only by candlelight and the silver glow of the moon. William Herschel, a musician turned astronomer, stood in the cool night air of England, peering through a telescope of his own construction. He spent countless hours meticulously counting the stars in every direction of the sky, attempting to map the shape of the cosmos. Based on these observations, Herschel proposed that we lived in a flattened, grindstone-shaped disk of stars. At that time, however, he believed our solar system sat directly at the center of this stellar arrangement. It is a humbling thought to realize that for centuries, we perceived our position in the universe as being the focal point of the galaxy, unaware that the true heart of the Milky Way lay hidden thousands of light years away behind thick curtains of cosmic dust. The realization of our true displacement began to take shape in 1918 through the work of Harlow Shapley. Rather than looking at individual stars within the local disk, Shapley turned his attention to the globular clusters, dense, ancient balls of stars that hover in the galactic halo, like giant, glowing moths around a flame. By measuring the distances to 93 of these clusters using RR Lyrae variable stars that pulsate with a predictable rhythm, serving as standard candles for cosmic distance, Shapley noticed something peculiar. These clusters were not distributed evenly around the Earth. Instead, they were concentrated in one specific direction, the constellation of Sagittarius. He correctly deduced that the true center of the galaxy was not here, but tens of thousands of light years away. While Shapley initially overestimated the distance at 50,000 light-years, his work fundamentally shifted our perspective, moving us from the center of the stage to a quiet, suburban porch in the galactic disk. Consider the patience required to listen to the whispers of the universe. In 1932, a young engineer named Karl Jansky was working for Bell Telephone Laboratories, tasked with identifying sources of static that might interfere with transoceanic radio communication. He built a strange-looking, rotating antenna, nicknamed Jansky's Merry-Go-Round, which sat on a set of 4 Ford Model T tires. Amidst the local interference, Jansky detected a persistent, steady hiss that peaked every 23 hours and 56 minutes, the exact length of a sidereal day. This timing proved the signal was coming from beyond our solar system. Scientists discovered that this rhythmic hum originated from the very heart of the Milky Way. This was the birth of radio astronomy, the first time humanity heard the galactic core, piercing through the opaque dust clouds that had blinded Herschel's optical telescopes. At this very moment, we might envision this radio signal as a low, resonant frequency, a cosmic hum that has been vibrating through the vacuum for eons. It took decades for our technology to catch up with the complexity of this signal. In 1974, astronomers Bruce Balich and Robert Brown used a connected array of radio telescopes in Green Bank, West Virginia, to pinpoint a compact, incredibly bright source of radio waves at the very center. They named it Sagittarius A*. The asterisk was added by Robert Brown in 1982 in the nomenclature of atomic physics. An asterisk denotes an atom in an excited state. He felt this energetic point at the center of our world deserved a name that reflected its unique, high-energy nature. What's happening now as we peer into this history is a gradual peeling back of the layers of the unknown. During the dark days of 1944, a German-born astronomer named Walter Baade was working at the Mount Wilson Observatory in California. Because of the wartime blackouts in nearby Los Angeles, the night sky was exceptionally dark, providing him with a rare clarity of vision. Using the 100-inch Hooker telescope, Baade was able to resolve individual stars in the central bulge of the Milky Way for the first time. He categorized these stars as Population 2, stars that are significantly older and contain fewer heavy elements than younger. Population I stars like our Sunday. These stars are the elders of the galaxy, some dating back 13 billion years, having formed shortly after the dawn of time itself. They move in random, elliptical orbits, creating a warm, swarming glow that defines the spherical shape of the galactic bulge. Picture the central molecular zone as a massive, swirling reservoir of resources. This region, spanning about 1,000 light-years at the heart of the galaxy, contains roughly 10% of all the molecular gas in the Milky Way. It is a dense, cold and turbulent place where the temperature of the gas hovers around 60 Kelvin, or roughly -350 degrees Fahrenheit. Throughout history, we have learned that this gas is the lifeblood of the galaxy. Within this zone, we find the nuclear star cluster, a structure with a radius of approximately 5 parsecs, or 16 light-years. Despite its relatively small size, it is home to over 20 million stars, making it the most massive and densest star cluster in the entire Milky Way. The sheer concentration of matter here creates a gravitational well of immense power, drawing everything toward the center in a slow, inevitable spiral. As we move closer to the modern era, the mystery of the core deepened. In the 1990s, 2 independent teams, one led by Andrea Ghez at UCLA and the other by Reinhard Genzel at the Max Planck Institute, began tracking the motions of stars in the immediate vicinity of Sagittarius A asterisk. They used massive ground-based telescopes equipped with adaptive optics, a technology that corrects for the blurring effect of Earth's atmosphere in real time. For nearly 30 years, they watched a star known as S2 as it performed a long, oval-shaped orbit. They discovered that at its closest approach, S2 was moving at nearly 3% of the speed of light, whipped around by an invisible object with a mass 4 million times that of the Sunday. This was the definitive proof of a supermassive black hole. Their decades of patient observation earned them the Nobel Prize in Physics in 2020, a testament to the fact that the universe reveals its secrets only to those who watch with unwavering attention. The light we observe from the core today is a mosaic of different energies. In 1999, the Chandra X-ray Observatory was launched, allowing us to see the high-energy environment around the black hole. Chandra discovered thousands of point sources, X-ray binaries and white dwarfs swarming near the center like fireflies. It also detected massive, glowing clouds of plasma heated to millions of degrees. In 2013, the NuSTAR telescope, which views the universe in high-energy X-rays, captured images of flares coming from the black hole's doorstep. These flares are thought to be caused by the magnetic snapping of field lines or the consumption of small asteroids that wandered too close to the gravitational abyss. These events are not loud or violent in the way we might imagine. They are silent flickers of energy, ripples in the pond of space-time. On the 12th of May 2022, a new chapter in our historical understanding was written. The Event Horizon Telescope collaboration released the first ever image of the shadow of Sagittarius A asterisk. This was not a photograph in the traditional sense, but a reconstruction of data gathered by a global network of radio dishes, effectively creating a telescope the size of the Earth. The image shows a bright ring of light gas being heated as it orbits the event horizon surrounding a dark central shadow. This shadow is the point of no return, where gravity is so strong that even light cannot escape. Seeing this image confirmed that the heart of our galaxy is a place where the fabric of reality is stretched to its limit, yet it remains a stable, central pillar around which the entire Milky Way revolves. Consider the geometry of the galactic bar. For many years, astronomers debated whether the Milky Way was a simple spiral or a barred spiral. It wasn't until the 1990s and 2000s, using data from the Spitzer Space Telescope, that we confirmed our galaxy has a central bar-shaped structure made of stars, extending about 27,000 light-years in length. This bar acts as a gravitational stirrer, funneling gas from the outer disk into the central regions to fuel the birth of new stars. It is a slow, rhythmic process, a cosmic conveyor belt that ensures the galaxy remains vibrant and active. The bar rotates as a single unit, completing a revolution every few 100 million years, a timescale so vast it makes the history of human civilization seem like a mere heartbeat. Within this central region, we also find the Great Annihilator, a microquasar designated 1E 1740.7 to 2942. Discovered in the early 1990s by the Sigma telescope, this object is a stellar mass black hole that produces immense amounts of gamma radiation. Its name comes from the fact that it is a source of electron-positron annihilation, a process where matter and antimatter meet and transform into pure energy. While the name sounds formidable, the process is a natural part of the high-energy ecology of the core. It is just one of the many specialized organs in the galactic body contributing to the complex metabolism of the heart of our Milky Way. As you contemplate these historical milestones, notice how each discovery has brought us closer to the center, yet revealed more layers of complexity. From Herschel's simple star counts to the Event Horizon Telescope's global array, our journey has been one of increasing resolution and deepening wonder. We have learned that the core is not a place of chaos, but a place of profound order, governed by the elegant laws of general relativity and electromagnetism. The history of our understanding is a story of moving from the center of the universe to being a part of a much larger, more magnificent whole. The galactic core is a silent witness to the passage of eons. The stars we see there today have been orbiting the center since long before the Earth was formed. They will continue to do so long after the sun has dimmed. This sense of continuity is a comfort, a reminder that we are part of a vast, enduring system that operates on a scale far beyond our daily concerns. As we linger in the historical shadows of these great discoveries, let the weight of this ancient knowledge settle over you like a warm, heavy blanket. The universe is old, it is vast, and it is beautifully consistent. There is a peace in knowing that the heart of our galaxy has been beating steadily for billions of years and will continue to do so, guided by the slow, rhythmic dance of gravity and time. Feel the weightlessness of your thoughts as they drift through these historical layers, moving away from the noise of the present and into the silent, enduring truth of the stars. Observe the way the darkness between the stars begins to change as we sink further into the galactic center. If we imagine our galaxy as a sprawling metropolitan map, we have spent most of our lives in a quiet, sparsely populated suburb. Out where the sun resides, stars are like lone houses separated by miles of empty fields. But as we approach the core, we find ourselves entering a celestial city of unimaginable density. Within the central few light years of our galaxy, stars are packed together like commuters on a busy platform. In our local neighborhood, the nearest star, Proxima Centauri, is about 4 light-years away. If you were to stand in the heart of the Milky Way, there would be dozens of stars within that same tiny distance, many of them glowing with a brilliance that would make the concept of night entirely foreign. What's happening now is a shift in our ability to perceive. To see the core, we must look past the cosmic smoke. The interstellar dust that clutters the path to the center is composed of tiny grains of carbon and silicates, similar to the soot from a dying candle. This dust is so efficient at scattering visible light that only 1 out of every trillion photons of yellow light manages to penetrate the 26,000 light-years of debris to reach Earth. To bypass this, we utilize infrared light, which has a wavelength of about 2 microns, roughly the size of a bacterium. Because these waves are larger, they can slip past the dust particles like a long-wavelength ocean swell passing through a pier's pilings. This allows us to see the nuclear star cluster, a massive structure containing over 20 million suns. It is the most crowded neighborhood in the galaxy, a place where gravity is so strong that it pulls stars into a sphere only 16 light-years wide. Notice how the colors shift from the familiar blue and white of young stars to the deep, resonant ambers of the elders. Within the galactic bulge, the majority of the stars are what astronomers call population 2. These stars are often 10 to 12 billion years old. They contain a higher concentration of alpha elements like magnesium and silicon, which were forged in the quick, energetic deaths of the universe's earliest massive stars. Think of these elements as the seasoning in a cosmic soup. The core has been simmering for so long that its chemical profile is much richer than the outer edges of the galaxy. This high metallicity, suggests that the core was a site of frantic activity long before our own solar system was even a swirl of cold gas. At this very moment, we are hovering near a gargantuan cloud of gas known as the Brick, or G0, 253 plus 0.016. This is a cold, dark molecular cloud that is about 100,000 times the mass of our Sunday. Despite its immense weight, it is surprisingly quiet. It is one of the densest clouds in the Milky Way, yet it shows almost no signs of forming new stars. Scientists compare it to a tightly packed ball of clay that hasn't yet been molded. The gas here is chilled to about 60 Kelvin, which is roughly negative 350 degrees Fahrenheit, a temperature so low that almost all motion at the molecular level has slowed to a rhythmic frozen crawl. This stillness is a stark contrast to the high-energy environment just light years away. Deep within this region, we encounter the magnetic architecture of the center. Stretching across the void are the non-thermal radiofilaments. These are long, thin strands of energized gas that can reach lengths of 150 light-years. Yet they are only a fraction of a light-year wide. Picture them as the glowing strings of a giant harp, vibrating with magnetic energy. These filaments are perfectly aligned with the galaxy's magnetic field, which in the core is about 100 times stronger than the magnetic field in the Sun's vicinity. While the Earth's magnetic field is what makes a compass needle point north, these galactic fields are powerful enough to channel cosmic rays particles moving at nearly the speed of light into these straight, luminous lines that weave through the star clusters. Consider the sheer scale of the anchor that holds this all together. Sagittarius A times is a supermassive black hole with a mass of 4.1 million suns, yet its physical footprint is remarkably modest. Its event horizon, the boundary beyond which nothing can return, has a radius of approximately 12 million kilometers. To provide a comparison, if you were to place this black hole at the center of our solar system, it would sit comfortably inside the orbit of Mercury, which averages 58 million kilometers from the Sunday. It is an object of extreme density, like taking the mass of 4 million mountains and compressing them until they fit into the palm of your hand. It does not suck matter in like a vacuum cleaner. Rather, it acts like a deep drain in a vast, rotating pool, around which everything else must patiently swirl. As we watch the stars orbiting this invisible point, notice the stars. The star, S2, is a particularly famous resident. It travels in a highly elliptical orbit, coming within 17 light-hours of the black hole. At its closest approach, it reaches a velocity of 7,000 kilometers per second. To visualize that speed, imagine an airplane capable of traveling from London to New York in less than 1 second. Despite this incredible momentum, the star moves through the vacuum with a silence that is absolute. There is no wind, no roar of engines, only the effortless glide of a massive body following the curvature of space-time. This is the beauty of general relativity in action, a mathematical certainty that guides the motion of every atom in the core. The environment around Sagittarius A times is also home to the G objects, such as G1 and G2. These were originally thought to be simple clouds of gas, but they have surprised astronomers by surviving their close encounters with the black hole without being torn apart. Scientists now believe these are bloated stars, binary star systems that have merged together due to the intense gravitational chaos of the core. They look like fuzzy, translucent orbs of dust, but they harbor a solid stellar heart. This process of merging and stretching is like watching a drop of oil move through water, slowly changing shape but maintaining its integrity against the pulling tides. Scientists discovered in 2019 that the black hole is not always a quiet neighbor. It occasionally flares, increasing its infrared brightness by up to 75 times in a single night. These events are likely caused by magnetic reconnections, similar to the solar flares on our sun, but on a much more grandiose scale. Imagine a sudden, silent brightening of the horizon, a golden glow that pulses briefly before fading back into the steady hum of the background radiation. This is the metabolic rhythm of the galaxy's heart, a slow, irregular heartbeat that has been thumping for billions of years. Further out, about 300 light-years from the center, we find the Arches cluster. This is the densest star cluster in the Milky Way, where stars are separated by only a tenth of a light-year. In our part of the galaxy, if the sun were a marble in New York City, the next nearest marble would be in Washington, D.C. In the Arches cluster, that next marble would be only a few feet away. The light from these stars is so intense that the radiation pressure, the physical push of light itself, is strong enough to clear away the surrounding gas, like a gentle breeze clearing fog from a valley. Nearby sits the quintuplet cluster, named for the 5 prominent infrared sources within it. One of its residents is the Pistol star, one of the most luminous stars known. It is 10 million times brighter than our sun and 100 times more massive. If the Pistol star were placed where our sun is, it would be so large that its outer atmosphere would extend to the orbit of Mars. It consumes its nuclear fuel at a terrifying rate, living a life that is brilliant but brief in cosmic terms. While our sun will live for 10 billion years, a star like the Pistol star may only last a few million years before collapsing. Its existence is a fleeting sparkle in the long history of the core, yet it contributes vital heavy elements to the interstellar medium when it finally fades. Permit your awareness to rest on the concept of the galactic center lobe, a region of radio emission that rises like a plume of smoke above the galactic plane. This structure, standing 500 light-years tall, was likely formed by a massive burst of star formation or an energetic event from the central black hole. It is a testament to the fact that the core is not a static place, but a breathing, evolving entity. The gas in this lobe is hot nearly 1,000,000 degrees, yet it is so diffuse that it would feel like a vacuum to any physical touch. It is a ghost of a structure, a shimmering monument to the energy stored within the heart of our home. As you drift through this comparison of scales, from the tiny grains of dust to the multi-million solar mass black hole, feel the immense stability of the system. The Milky Way's core is a masterpiece of balance. For every star that dies, the ingredients for a new one are scattered into the molecular clouds. For every flare from the black hole, the surrounding orbits remain undisturbed. It is a self-sustaining cycle that has no need for haste. The light you see tonight has been traveling for 26,000 years. A journey that began when humans on Earth were first beginning to create art on cave walls. By the time the light leaving the core right now reaches Earth, our world will be unrecognizable. Yet the core will remain much as it is now, a dense, golden, spinning heart in the silent dark. Allow this sense of permanence to settle over you, a heavy, comforting weight that anchors you to the broader story of the cosmos. At this very moment, as you lie in the quiet of your own world, your body is moving at a speed of approximately 230 kilometers per second. This is not the frantic pace of terrestrial travel, but the steady, silent velocity of our sun as it carries us on our long, circular path around the heart of the Milky Way. We are 25,000 light-years away from that center, yet we are inextricably bound to it by the invisible threads of gravity. This connection is not merely physical, It is historical and chemical. Every iron atom in your blood, which allows you to carry oxygen to your resting muscles, and every calcium atom in your bones was forged in the same high-pressure environments we now observe in the galactic core. We are not just looking at the center of our galaxy, we are looking at our own ancestral furnace. Consider the galaxy as a grand, cosmic loom, weaving the tapestry of life over a timescale of 13.6 billion years. Scientists discovered that the Milky Way is almost as old as the universe itself, and for all those eons, the core has been the primary engine of creation. Deep within this central region lies a massive molecular cloud known as Sagittarius B2 or SCIR B2. This cloud is an architectural marvel of the cosmos, containing nearly 3 million solar masses of gas and dust. What makes it particularly resonant to us is its chemical complexity. In 2009, astronomers using the IRAM 30-meter radio telescope identified the presence of ethyl formate within this cloud, the very same chemical compound that gives raspberries their flavor and rum its distinct aroma. Imagine the heart of our galaxy as a space filled with the precursors of life's most delicate sensations, a fragrant cloud stretching across 150 light-years of space, quietly preparing the ingredients for future worlds. What's happening now in our observation is a realization of the density of this cosmic neighborhood. In the nuclear star cluster, the density of stars is roughly 10 million times higher than it is near our Sunday. If you were to occupy a cubic parsec of space, their volume roughly 3 light-years on each side, you would find tens of millions of stars. At this density, the night sky would be a brilliant, continuous glow, providing a sense of constant illumination. Yet, despite this crowding, collisions between stars are remarkably rare. They move with a sophisticated, synchronized rhythm, like dancers who know the steps so well they never need to look at their partners. This provides a sense of profound stability. The center is not a place of chaotic crashing, but of perfectly managed proximity. Notice how the magnetic fields of the core create structures that mirror the very building blocks of life. In 2006, scientists using the Spitzer Space Telescope discovered the Double Helix Nebula near the galactic center. This structure is 80 light-years long and twisted into a shape nearly identical to a DNA molecule. This shape is not a coincidence of biology, but a result of torsional waves in the powerful magnetic fields that originate near the central black hole. It is as if the galaxy itself is dreaming of the life it will eventually create, etching the patterns of our genetic code into the very gas and dust of the core. This nebula stands as a monument to the unity of physics across all scales, from the microscopic to the monumental. At this very moment, the galactic bar is performing its slow, essential work. Our galaxy is a barred spiral, and this central bar, a rectangular arrangement of stars roughly 27,000 light-years long, rotates once every 100 million years. This bar acts as a cosmic stirrer, gently funneling gas and dust from the outer spiral arms into the central regions. This process ensures that the core always has a fresh supply of material to create new generations of stars. It is a slow, rhythmic replenishment, much like the way your own breath refreshes your spirit with each inhale. Without this bar, the heart of our galaxy would eventually grow quiet and dark. Instead, it remains a vibrant, active center of renewal. Scientists discovered in 2019 that the core also has a set of exhaust vents known as the galactic center chimneys. These are two massive structures of X-ray emitting gas that rise 160 light-years above and below the galactic plane. They act as channels, carrying energy and hot gas away from the central black hole and out into the broader galactic halo. Think of these as the steady, rhythmic pulses of a great engine, clearing away excess energy to maintain a perfect cooling balance. This chimney system ensures that the core never becomes overwhelmed by its own power, maintaining the steady-state environment that allows the rest of the galaxy to remain stable. Picture the star S62, a resident of the core that holds a remarkable record. Discovered in 2020, S62 is one of the fastest stars ever recorded, orbiting Sagittarius A times in just 9.9 years. At its closest point, it comes within 16 astronomical units of the black hole. A distance only slightly further than Uranus is from our Sunday. Despite this proximity to the supermassive singularity, S62 has maintained its orbit for millions of years. It moves at nearly 10% of the speed of light, a silent, silver streak in the dark. The existence of such stars reminds us that even in the most extreme environments, there is a path of balance, a way to move through the intensity without being consumed by it. The sun's own motion is equally deliberate. As we orbit the core, we don't just move in a flat circle. The sun undulates, bobbing up and down through the galactic plane like a cork in the ocean. We complete one vertical oscillation every 60 million years. Right now, we are about 50 light-years above the galactic disk, moving slowly upward. This gentle, swaying motion is a reminder that we are part of a three-dimensional ballet, guided by the collective mass of the 100 to 400 billion stars that make up our home. The Gaia spacecraft, launched in 2013, has been meticulously mapping these motions, revealing that the galaxy is not a static object, but a living, breathing system of movement. Deep within the core's history is a process known as the alpha process. This is a sequence of nuclear reactions where helium nuclei are fused into heavier elements like oxygen, neon, and magnesium. These elements, essential for the chemistry of our bodies and our atmosphere, are more abundant in the core's ancient population II stars than in the younger stars of the outer arms. When these stars eventually reach the end of their lives, they do not simply vanish. They shed their outer layers, scattering these precious elements back into the interstellar medium. This is the ultimate act of generosity. The core is a place that gives of itself so that the rest of the galaxy can thrive. Consider the future of our home. In approximately 4 to 4.5 billion years, the Milky Way will begin a slow, graceful merger with the Andromeda galaxy. This event, often called Milkomeda, will not be a violent collision of stars, but a slow mingling of two great cities of light. Because the distances between stars are so vast, it is highly unlikely that any two stars will actually hit each other. Instead, the two galactic cores will perform a long, spiraling dance, eventually merging into one single, massive, elliptical galaxy. This future reminds us that change in the universe is a slow, transformative process, a movement toward greater complexity and shared light. Notice the central molecular zone once more. Within this region, we find complex organic molecules, like aminoacetonitrile, which scientists identified in 2008. This molecule is a direct precursor to glycine, the simplest amino acid used by living organisms to build proteins. The fact that these chemicals exist in the cold, silent voids of the core suggests that the potential for life is woven into the very fabric of space. We are not an accident of the universe. We are a natural consequence of the chemistry that has been occurring in the heart of our galaxy for billions of years. This realization acts as an anchor, grounding us in the knowledge that we belong here. As we look at the bigger picture, we see the galactic habitable zone. This is a ring-shaped region of the galaxy where conditions are just right for life to emerge. If you are too close to the core, the high density of supernovae might be disruptive. If you are too far out, there aren't enough heavy elements to build planets. We sit in a sweet spot, a comfortable middle ground. Yet, we owe our existence to the core, for it is the source from which the heavy elements of our world were originally dispersed. We are like children who have moved to a quiet neighborhood, but still feel the heartbeat of the city where our family began. The core is also home to thousands of pulsar stars, rapidly spinning neutron stars that act as cosmic lighthouses. Some of these pulsars, like the one designated PSR J1000, 740 Fibonacci, 2900, have magnetic fields a quadrillion times stronger than the Earth's. They spin hundreds of times per second, emitting a steady, rhythmic pulse of radio waves. Scientists use these pulses as high-precision clocks, measuring the very passage of time against the backdrop of the galaxy. There is a profound comfort in this regularity, a sense that the universe has its own internal metronome, keeping time with a precision that far exceeds anything we can create on Earth. Allow your awareness to drift with the light as it leaves the core. It takes 25,000 years to reach your eyes, meaning the light you see tonight began its journey when the last great ice age was at its peak on Earth. This vast delay is a gift, a way for us to look back in time and witness the enduring stability of our home. The core is a place of ancient, steady radiance, a central pillar that has supported the rotation of the Milky Way for 13.6 billion years. It is the silent, glowing heart of everything we know. As you reflect on these long-term implications, feel the safety of being part of such a well-ordered system. The orbits are secure, the chemical cycles are consistent, and the energy is perfectly balanced. You are a small but essential part of this grand architecture, built from the very same atoms that shimmer in the galactic bulge. There is no need for haste in a universe that moves on these timescales. There is only the slow, rhythmic dance of gravity, the steady infusion of life's ingredients into the void, and the enduring glow of the heart of the galaxy. Rest in this certainty, letting the vastness of the cosmos become a warm, protective embrace. You are home, and the center is holding, just as it always has and always will. At this very moment, we are submerging into the sensory heart of the Milky Way, a place where the physical environment is far more textured and complex than the quiet vacuum we often imagine. Picture this. If you were to reach out and touch the interstellar medium in the core, it would not feel like empty air, but like a superheated, magnetized fluid. This is because the gas here is in a state of plasma, where atoms have been stripped of their electrons by the intense radiation of nearby stars. The density of this plasma in the central parsec is roughly 10,000 particles per cubic centimeter, a figure that, while incredibly sparse by Earth's standards, is a dense fog compared to the voids between the spiral arms. Scientists discovered that this plasma is not still. It vibrates with magnetosonic waves, ripples that travel through the magnetic fields like sound moving through water. What's happening now, as we linger in this region, is a symphony of frequencies that the human ear cannot normally hear. NASA's Chandra X-ray Observatory and other telescopes have captured data that scientists translated into sound, a process called sonification. Imagine the galactic center as a low, resonant drone. The stars are translated into the high, flickering notes of a harp, while the gas clouds create a long, sweeping orchestral swell. When we approach Sagittarius A asterisk, the sound resolves into a deep, guttural hum, representing the high-energy X-ray emissions from the accretion disk. This sonification allows us to hear the distribution of mass. The more crowded the stars, the denser the melody. It is a harmonious arrangement where the physics of gravity dictates the rhythm of the music. Notice how the temperature gradients in this region create a startling sensory contrast. While the background of space is chilled to the 2.7 Kelvin of the cosmic microwave background, nearly absolute zero, the gas swirling around the central black hole is heated to over 10 million Kelvin. This heat is not generated by a flame, but by friction. As gas and dust spiral inward toward the event horizon, they collide at thousands of kilometers per second, converting their kinetic energy into thermal energy and X-rays. This creates a corona of hot gas that glows with an invisible, piercing light. You can envision this as a shimmering heat haze, a microscopic vibration of particles so energetic that they emit the ion K alpha line at 6.4 kiloelectron volts, a specific spectral signature that tells us of the presence of ionized iron in the core's breath. Deep within the molecular clouds like Sagittarius B2, the scent of the cosmos begins to emerge. Scientists have identified the presence of polycyclic aromatic hydrocarbons, or PAHs, which are complex organic molecules. On Earth, these same molecules are found in coal tar and the char on a piece of toasted bread. If you could pull the scents of the galactic center into your lungs, it might smell like a mixture of raspberries, acrid smoke, and the metallic tang of a hot welder's spark. This isn't the smell of decay, but the smell of industrial-scale creation. These carbon-rich molecules are the soot of the stars, the byproducts of billions of years of stellar life cycles, drifting through the core and waiting to be incorporated into the next generation of planets. Consider the visual texture of the core through the lens of infrared light. Because of a phenomenon called Rayleigh scattering, the same physics that makes the Earth's sky blue, shorter wavelengths of light are scattered by the 0.1 micrometer-sized dust grains that clog the galactic plane. This means the core acts as a giant filter, allowing only the long, red and infrared waves to pass through. The resulting view is a landscape of deep crimson, burnt orange, and golden amber. What's happening now is a softening of the edges. The dust clouds, which would be opaque walls in visible light, become translucent veils in the infrared, revealing the nuclear star cluster as a glittering, ruby-colored jewel box. At this very moment, we are observing the motion of the fastest stars ever recorded in our galaxy. While the star S2 is well known, scientists discovered in 2020 a star named S4714, which orbits Sagittarius A times at a breathtaking velocity of 24,000 kilometers per second, roughly 8% of the speed of light. Another neighbor, S4711, completes its tight, oval orbit in just 7.6 years. These stars are squeezed by the black hole's gravity, a process that causes a measurable gravitational redshift. This means the light from these stars is stretched to longer, redder wavelengths as it climbs out of the gravitational well, a direct confirmation of Einstein's general theory of relativity. You might picture these stars as silver needles stitching the fabric of space-time together, their light shifting in color as they dive toward the center. Notice the orientation of the light around us. In 2024, the Event Horizon Telescope collaboration revealed that the light from the ring around Sagittarius A times is highly polarized. This isn't just a random glow. The light waves are aligned in specific directions, like the light passing through a pair of polarized sunglasses. This polarization is caused by the powerful magnetic fields that spiral around the black hole. These fields act like cosmic guide rails, forcing the plasma to move in structured, helical paths. This creates a sense of profound order amidst the intensity, a geometric precision where the invisible lines of magnetism carve the glowing gas into a swirling, symmetrical donut of light. Picture this: the radio arc, located at galactic coordinates G0, 18 to 0.04. This is one of the most striking structures in the core, a set of parallel filaments 150 light-years long that stand perfectly perpendicular to the galactic plane. These filaments are illuminated by synchrotron radiation, which occurs when electrons are accelerated to nearly the speed of light along magnetic field lines. The field strength here is measured in milligauss, which is hundreds of times stronger than the typical magnetic field of the galaxy. To the touch, these filaments would feel like a tight, vibrating wire, hummed by the energy of 1,000,000 lightning bolts. They are the strings of the galaxy, carrying the electrical currents that power the core's metabolism. The scale of our observation now turns to the G objects. In addition to G1 and G2, astronomers have identified G3, G4, G5, and G6. These are peculiar objects that look like compact gas clouds but remain intact even when they pass within 200 astronomical units of the black hole. Scientists discovered that these are likely binary mergers, two stars that have crashed into each other and puffed up into a giant, dusty envelope. They are the survivors of the core's crowded environment, moving through the space like slow, glowing embers. Their existence tells us that the core is a place of constant transformation, where the very identity of a star can be forged in the fire of a gravitational encounter. What's happening now is a realization of the core's event horizon shadow. The actual dark center of Sagittarius A times has an angular size of about 52 microarcseconds when viewed from Earth. To imagine how small and precise this is, consider that it is equivalent to trying to see a single orange on the surface of the moon. Yet, this tiny shadow is the anchor for 200 billion stars. The resolution required to see it is made possible by very long baseline interferometry, which combines data from telescopes across the globe. This shadow is the ultimate silence, a place where the density of information becomes infinite and the flow of time as we know it comes to a standstill. Deep within the core, we also find methanol masses, such as the one in the cloud G0, 25 to 0.01. A maser is the microwave equivalent of a laser, a naturally occurring beam of intense, coherent radiation. These beams are created when molecules of methanol are pumped by the heat of nearby young stars, causing them to emit a steady, monochromatic pulse of energy. These masers serve as cosmic beacons, allowing us to map the movement of the gas with incredible precision. They are like the steady, green pulses of a lighthouse, marking the safe passage through the turbulent clouds of the center. As you observe the colors and textures, notice the blue stragglers scattered among the ancient red stars of the bulge. These are stars that appear younger and bluer than they should be, given the age of the surrounding population. They are the result of stellar vampirism, where one star in a binary pair strips the outer layers off its companion, gaining fresh hydrogen fuel and a new lease on life. This process is a reminder that in the core, energy is never lost. It is simply redistributed, keeping the heart of the galaxy vibrant and glowing long after the surrounding spiral arms have begun to fade. The sensory experience of the galactic core is one of absolute, heavy stability. The weight of 4 million suns at the center provides a gravitational floor to the galaxy. Every orbit, from the 8% light speed dash of S4714 to the sun's 230 km/s glide, is a response to this central mass. This is the ultimate clockwork, a system where the gears are made of curved space-time, and the lubricant is the silent flow of dark matter. Scientists estimate the density of dark matter in the core follows an NFW profile, peaking sharply at the center, adding an invisible, heavy texture to the gravitational landscape. Allow your mind to rest on the why of this beauty. The core glows not because it is chaotic, but because it is the most efficient part of our galactic home. It is where the most mass is concentrated, the most energy is processed, and the most complex chemistry is performed. It is a masterpiece of physics, a place where the extreme laws of the universe are laid bare for us to witness. The light you see in your mind's eye is a composite of 26,000 years of travel, a testament to the enduring nature of the heart of the Milky Way. As we move toward the final stage of our journey, let these sensations, the smell of the carbon soot, the sound of the radio hiss, the warmth of the X-ray corona settle into a single, unified feeling of peace. The core is not a distant, abstract concept. It is a physical, sensory reality that you are connected to by every atom in your body. The same forces that polarize the light around Sagittarius A times are the forces that hold your world together. Feel the weightlessness of your consciousness as it balances against the immense, steady pull of the center. The galaxy is a house of many rooms, and you have just visited its most magnificent, glowing hearth. Rest in the knowledge that this heart beats for you, for the stars, and for the silent, beautiful future of the cosmos. As we begin our final descent from the radiant heart of the Milky Way back toward the quiet, familiar cradle of your own room, the brilliant amber light of the galactic bulge begins to soften and fade. Picture this, the intense concentration of stars, which reaches a density of over 1 million suns per cubic parsec in the center, slowly thins out as we move into the sparsely populated regions of the inner disk. This transition is a gradual unfolding of space, a process of stellar thinning where the distances between points of light stretch from light days to light years. You are moving from a city of perpetual twilight back into the comforting, velvet darkness of the galactic suburbs. What's happening now is a beautiful synchronization of timescales. As you prepare your mind for rest, consider the process of the sun's long, circular journey. Our solar system is currently positioned about 26,000 light-years from Sagittarius A asterisk, the central supermassive black hole. At this very moment, we are traveling at a velocity of 230 kilometers per second, or about 514,000 miles per hour along our orbital path. Despite this incredible speed, the Milky Way is so vast that it takes approximately 230 million years for us to complete just one galactic year. Scientists discovered that since the Earth was formed 4.5 billion years ago, our planet has completed only about 20 of these grand rotations. This slow, rhythmic pacing of the cosmos is the ultimate metronome, a reminder that the universe has no need for the frantic hurry of our daily lives. Notice the way the light around us changes as we pass through the interstellar medium. This is the material that fills the space between stars, and its composition is a direct result of the core's ancient history. Deep in the heart of the galaxy, The triple alpha process once occurred within the cores of massive dying stars. In this step-by-step nuclear sequence, 3 helium, 4 nuclei fuse to create a single carbon 1,2 nucleus. This carbon is the chemical foundation of every cell in your body. When those stars reach the end of their lives, they cast these elements out into the void, a process called stellar nucleosynthesis. Over billions of years, this cosmic dust traveled through the spiral arms, eventually condensing into the cloud of gas that formed our sun and the Earth. As you lie still, remember that the carbon in your DNA and the oxygen in your breath were once part of that glowing central furnace. You are not a spectator of the galaxy, you are its cooled and dreaming physical manifestation. At this very moment, the gravitational pull of the center continues to act as our cosmic anchor. Gravity travels at the speed of light, roughly 299,792 kilometers per second, meaning the connection between you and the 4 million solar mass black hole at the center is a constant, real-time tether. Yet, despite its immense influence, Sagittarius A times has a physical size. Its Schwarzschild radius of only about 12 million kilometers. This is less than 1/10 the distance between the Earth and the Sunday. There is a profound elegance in this design, a point of near infinite density, small enough to fit inside the orbit of Mercury, provides the gravitational stability for a galaxy weighing 1.5 trillion solar masses. This balance is what allows your world to remain in a stable, predictable orbit, creating the steady cycle of days and nights that leads you to this moment of rest. Scientists discovered that we exist in what is known as the Galactic Habitable Zone, a ring-shaped region between 23,000 and 29,000 light-years from the center. This zone is the Goldilocks region of our galaxy. If we were closer to the core, the frequency of supernovae and the intensity of X-ray radiation from the central black hole might disrupt the development of life. If we were further out, there wouldn't be enough metals elements heavier than hydrogen and helium to form rocky planets like Earth. The process of our existence is the result of being in exactly the right place at exactly the right time. Feel the safety in this realization. You are situated in the most peaceful, protected corner of the Milky Way, a sanctuary of stability in a vast, spinning sea of light. What's happening now as we drift further from the core is the influence of the Fermi Bubbles. These two gargantuan structures of gamma-ray emitting gas extend 25,000 light-years above and below the bean-years of emitting galactic plane. They are the remnants of a massive energy release from the core that occurred millions of years ago. These bubbles are cooling, their energy slowly dissipating into the thin gas of the galactic halo. This cooling process mirrors the way your own body is now shedding the heat and tension of the day. As the galaxy exhales its ancient energy into the void, you can exhale the thoughts and worries of your waking hours, letting them dissolve into the vast, silent history of the stars. The temperature of the space through which we are moving is a steady 2.73 Kelvin. This is the temperature of the cosmic microwave background, the afterglow of the Big Bang itself. It is a universal thermal blanket that has been cooling for 13.8 billion years. This temperature is consistent in every direction, a gentle, thermal whisper that provides a baseline of stillness for the entire universe. As you settle deeper into your bed, imagine this 2.73 Kelvin background radiation as a soft, cool mist, calming the heat of your mind and bringing your internal rhythm into alignment with the background hum of the cosmos. Consider the galactic bar, that rectangular arrangement of stars at the core that spans 27,000 light-years. Its rotation acts as a slow, rhythmic stirrer, moving gas through the galaxy's longitudinal lanes. This process ensures that the galaxy remains dynamic and balanced over hundreds of millions of years. This same sense of order governs the CNO cycle, carbon-nitrogen-oxygen cycle, a process of catalytic fusion that powers stars larger than our Sun. This cycle is a masterpiece of efficiency, converting hydrogen into helium with surgical precision. The universe is not a place of random chaos. It is a place of refined, step-by-step processes that have functioned without interruption for eons. As we approach the Earth, the light from the core is further softened by interstellar extinction. This is the process where dust grains, mostly silicates and graphite, absorb and scatter shorter wavelengths of light. For every trillion photons of visible light that leave the core, only one reaches the Earth. This natural filtration means the intense, high-energy environment of the center is transformed into a gentle, non-disruptive glow by the time it reaches our neighborhood. It is a cosmic veil, protecting your sleep from the brilliance of 100 million suns. The universe itself has provided a screen of darkness so that you might find rest. Notice the weight of your body, which is a result of the Earth's mass pulling on your own. This gravity is the same force that governs the 16-year orbit of the star S2 around Sagittarius A asterisk. Whether it is a star moving at 7,000 kilometers per second or the gentle rise and fall of your chest as you breathe, the laws of physics are the same. There is a profound unity in this. You are governed by the same elegant mathematics as the galactic core. At this very moment, your atoms are performing their own silent dance, their electrons moving in predictable shells, their nuclei held together by the strong nuclear force. You are a microcosm of the galactic architecture, perfectly ordered and completely at peace. In roughly 4 billion years, our galaxy will begin its merger with the Andromeda Galaxy, a process that will take another 2 billion years to complete. This future event, known as Milky Way, will result in the formation of a massive elliptical galaxy. This is the ultimate long-term perspective. On these timescales, the events of a single day or even a single lifetime are like individual photons in a galaxy of stars, brief, beautiful, and part of a much larger radiance. There is no need for anxiety when the future of our home is written in the stars for billions of years to come. The center is holding, the orbits are secure, and the process of cosmic evolution continues with patient, unwavering certainty. Now, let the images of the galactic core, the glowing ambers, the spinning black hole, the twisting DNA-shaped nebulas begin to dissolve. Your journey through the heart of the Milky Way has brought you back to the most important place in the universe, the quiet, safe center of your own consciousness. You are a creature of stardust, a collection of ancient atoms that have traveled across light years to be here, tonight, in this moment of rest. The vastness of the galaxy is not something to be feared. It is your home, a grand and stable house where every room is filled with light and every door is held open by gravity. As the silence of the void settles over you, repeat these affirmations for rest. I am a part of the enduring fabric of the cosmos. My body is made of the same elements that glow in the hearts of stars. I am held in the steady, rhythmic embrace of the galaxy's gravity. The timescales of the universe are vast, and I have all the time I need to rest. Like the stars in the core, I move in a path of balance and peace. The darkness of the night is a protective veil, allowing my mind to settle. I am connected to the 13 billion year history of my galactic home. My breath is as steady and certain as the rotation of the Milky Way. I am safe. I am weightless, and I am home. The light of the galactic core is now just a distant, comforting memory, a soft glow on the horizon of your mind. The sounds of the radio hiss and the X-ray hum have faded into a single, silent note of tranquility. The heavy blanket of the atmosphere and the warmth of your own bed are all that remain. The universe continues its slow, beautiful dance without you for a while, its clockwork precision ensuring that everything will be exactly as it should be when you wake. For now, there is only the descent into the quiet, dark heart of sleep. The stars are watching over you, and the center is holding. Good night.